Another one is concentricity, like I mentioned. Maybe you're struggling to get concentricity. How do you troubleshoot that? Well, there is no simple way to measure the working concentricity of the spindle. We talked a little bit about spindle alignment. Even with conventional machines the way it is now, you bring in a tech from Citizen or whatever, they'll check the sleeve concentricity. The sleeve, they have to check it without a collet or anything into it because you can't get to the sleeve with the collet in there. The collet's in the sleeve. You need to measure that surface that the collet seats on. So they'll put an indicator on the sleeve surface to see if it's running true. That is not under operating conditions. That's under no load condition because there's no collet, no clamping force. When you put a clamping force on it, it's pushing against the nut. The end of the spindle is being compressed, the sleeve, the toggle mechanism to push the sleeve forward. All that puts stress on the spindle and tweaks it. And a machinist that I admire on Instagram, Robin Renzetti is his name. He has a statement. He says, everything's rubber. So you think of metal as this solid thing, but everything flexes. So when you're in a spindle, even though it's solid, hardened steel, when you apply pressure on it, it'll flex a little bit. So if your spindle cap nut is a little bit crooked, and then when you put clamping force on it, it forces your collet crooked, and then it's off. With our system, you have the cartridge, which is ground to within millionths, 50 millionths or better accuracy. You know that it's a solid piece of high chromium, extremely hard tool steel or die steel, ground to within 50 millionths. You put that in the machine, then you put it in the clamp position. There's no collet in there, just our cartridge is clamped. It has this super precise nose. You can use that like a gauge. So if you get that to run true, the collet will run true. If you put the cartridge in and it's running off, you have to fix that. So you don't even waste your time trying different collets. So you reduce the skill level because when you have a problem, you fix the actual problem, the cause of the problem, not chasing your tail, troubleshooting it. I mean, I had a customer in San Diego. I go down there, and he said, "Yeah, we can't get your cartridge to run true. You know, something's wrong with your cartridge." I said, "No, I'll come down." I went down there. I was talking. It was the manager of the area, who was also a machinist, talking to me, saying, "Yeah, well, you know, your thing's just not working in this machine. You know, can you find out what's wrong with your cartridge?" And I said, "Well, don't send me the cartridge. I'll come down. We'll look at the machine." But go down there, and sure enough, put the cartridge in, and it would run out 7/10. Then you'd open and close it, it would run out 3/10. Then you'd open and close it, and run out 8/10. It was like varying all over. He says, "Yeah, something's weird with your cartridge." I said, "That's not the cartridge. Something's going on with the machine." To make a long story short, he had the OEM machine tech come in. He checked the spindle sleeve with no load, and everything runs true. Everything runs great. He said the machine doesn't have a problem. He didn't say anything about our cartridge. He just said, "The machine's running true. That's not a problem." And it did appear to run true when under no load. You put our cartridge in, it was all over the place. We were able to show that they had a spindle bearing issue which did not arise until you put a clamp load on it. And then the sleeve would shift. Well, they ended up changing out the spindle liner and the bearings, got the spindle to run true, and the setup guy down there, I mean, he was like, "Yes, I knew there was something wrong with that machine, but I just couldn't prove it because under no load, it was running fine." When you put that stress, it shifts the bearing location. Maybe they ride on the racing a little, because under load is where you use the machine the most, right? When it's clamped. So if the preload on the bearing is altered by the clamping force, it's going to ride in a slightly different spot than it would when it's running free. All I know is when they changed out the sleeve liner and the bearings, the problem went away.
Yeah.